Hey everyone, this short video is for AC Theory Level 1, Lesson 3. We're going to be looking at a couple of questions that involve inductive reactance and how to solve those couple problems. First, I'd like you guys to remember from our lecture the formula for inductive reactance, which is 2 pi times the frequency in hertz times the inductance in henries is how we find inductive reactance. And inductive reactance is measured in ohms. Another important concept that you guys learned previously is Ohm's law, of course. And with Ohm's law, since inductive reactance is measured in ohms, we can substitute resistance for inductive reactance to figure out circuit parameters if we know voltage and current, or even voltage and inductive reactance to find current. So, first thing we're going to look at today is going to be question 13 in lesson 3. Now, question 13 states a purely inductive 120 volt 60 hertz circuit draws 2.7 amperes. What is the reactance of the circuit? Now, I always think it's important to write down what is the parameter that they're looking for. So in your notes you should say inductive reactance is what they're looking for, and we actually already just viewed that formula. So let's go ahead and see what they gave us for circuit parameters. They told us that there is 120 volts, there is 60 hertz, and 2.7 amps. Now, being that they gave us the voltage and the current, and they're looking for inductive reactance, we can then just compute this with that formula of Ohm's law. So 120 volts over 2.7 amps would equal the inductive reactance. So it's as simply as dividing 120 volts by 2.7 amps to find out what the inductive reactance opposing current flow is in that circuit. And on your calculator, it comes out to be 44.4 ohms of inductive reactance. So then we go ahead and enter that into our answer. And remember, do not forget to select the correct measurement of ohms. If I check that answer, you can see it came in correct. All right. The next question here is 14 that I want to take a look at with you. Now, on question 14, they're asking a coil has an inductance of 250 millihenries. Find its inductive reactance at 60 hertz. So again, they're looking for inductive reactance. And we also know the formula for inductive reactance is 2 pi times frequency times the inductance in henries. So they gave us a frequency of 60 hertz in the question, and they also told us 250 millihenries. Now, being that it's millihenries, we need to convert the millihenries into the base unit of henries. And that would be moving the decimal 3 places, giving us 0.25 henries. Then it's just putting the components into this formula where it then equals 2 times pi times the 60 hertz times 0.25. And that will give us what the inductive reactance is. Now I want to show you on the calculator how I would compute that as easy as possible. So turning on my calculator, if I need to do 2 pi times 60 times 2.5, I can just hit the 2 key, hit the pi key, and then hit the 60 key for frequency. Now, I then would have to hit the multiplication key to enter the 0.25 henries, and I could then hit enter. We get a sum of 94.24777. Going back to the question, it does not specify exactly where to round that decimal to. So let's go ahead and just round that decimal to the hundredths, which is 2 decimal places. So if I enter 94.25, and then make sure I select ohms because it is inductive reactance, and go down to the check button. And there it gave us the okay that we got that correct. So let's move down to the next question, which is question 15. Now question 15 states a 50 millihenry coil is connected to a 60 hertz 240 volt source. How much current flows? So on this question, they're not asking us for inductive reactance, they're asking us for current, or current total. And then looking at what else they gave us that it has a 50 millihenry coil. It's operating at 60 hertz, and there's 240 volts applied to the circuit. So if current is the question, what we need to do is first find how much opposition there is in the circuit when 240 volts are applied. And being that we have the henries and the hertz, we can then find what the inductive reactance is. So inductive reactance is going to be 2 pi times the 60 hertz times 50 millihenries. Don't forget to move your decimal point and put it into base units. So this would be 0.05 on our calculator. Going over here to our calculator, let's clear out our last problem and enter 2 pi times 60 times our inductive reactance of 0.05 millihenries. That's going to give us 18.85 ohms of inductive reactance. So we want to keep that in mind because, again, inductive reactance isn't what they're asking us for. But now, in like the previous questions, if we have voltage and now we have inductive reactance, or I did say 8.5 after I rounded it, ohms of inductive reactance, we can then simply take the 240 volts divide it by the resistance or reactance of 18.85, and that should give us current. Back over on our calculator, I still have that last solution pulled up on my calculator, so then I can go ahead and use this by using the answer function on my calculator. So if I just start a new problem and put 240 volts divided by the answer that I had displayed, I would hit second, the answer key down here, and equals. And it gives us 12.73. Now on this particular question, they do specify that they want the final answer to 1 decimal place. So that would give us 12.7, and because it's current, it is amperes. Then we would want to go ahead and check that problem, and it looks like we were correct. The last question that I want to look at with you guys is going to be question 16. Question 16, much like question 15, is again another two-step problem. We look at what they ask us, and it is an inductor in a 60 hertz circuit has 80 volts across it with 4 amps flowing through it. What is the final inductance of the inductor? Now, as I said before, the first step is figure out what they're going to ask you. They are asking us inductance, and inductance is measured in henries. So this is the ultimate question. Go ahead and fill in your notes, pull out all the other parameters that they gave you. They told us first there was 60 hertz, and they have 80 volts applied to the circuit, and then they also told us that there is 4 amps flowing. Now we can use this to figure out what the inductive reactance is, which is the opposition to current flow, is one of the parameters we do not have. Again, using Ohm's law with volts and amps, we can find out what the inductive reactance is, which gives us, we plug in our knowns of 240 volts divided by a current of 4 amperes, and that's a pretty easy problem. That would be 20 ohms. So now I know my inductive reactance is 20 ohms. I can move on to the next step, which is to find out henries. We can use the formula for inductive reactance and plug in everything that we do have. Well, inductive reactance is 20 ohms. 2 pi doesn't change. We have a frequency stated here of 60, but we do not know what inductance is in henries. So this is what they're looking for. We can apply a little bit of algebra real quick to figure out the solution. So on this side of the equation, if I divide the whole thing by 2 pi 60, that's going to cancel this out. We have to do the same over here. And since that's canceled out, this is going to equal our inductance in henries. So quickly back over the calculator. Now that we're on a different problem, let's make sure we clear out what we had on the calculator and simply take the 20 ohms of inductive reactance and then divide it by 2 pi 60. Now be careful of order of operations with this problem, because if I just go ahead and enter 2 pi 60, it's going to divide 20 by 2 before it multiplies pi and 60. So we want to make sure we use some parentheses on the bottom. 2 pi 60, close the parentheses, and it shows us that we have 0.053. Now, back on the problem, that is 0.053 henries. And because they're asking us in henries and round the final answer to 3 decimal places, that would be, as I said, 0.053 would be the solution. Now checking that problem, it looks like we're right. There is a couple more problems left with this lesson, and they follow the same steps that we just walked through. So go ahead and solve those problems, and I'll see you in class.